Alright, welcome to this video. This one is dividing complex numbers, and I want to take you back on a little trip in the past to maybe your 3rd, 4th, or 5th grade. I'm not really sure exactly when they teach adding fractions, but you and I both know that 3/5 plus 1/4, you can't do it just like this. You have to get a common denominator. Now our fancy calculator is pretty sweet about that. It's 3 over 5 plus 1 over 4. It will do it. It's 17 over 20, but watch how it's working in the insides of that calculator. It's taking this, it's trying to get a common denominator. You can see that the common denominator is going to be 20. Well, it's multiplying this first fraction, and it's going to multiply it by 4 in the denominator, and of course you have to multiply the top by the same thing. Well, I don't remember my teacher explaining this necessarily in elementary school. She might have, but 3/5, you're multiplying it times 1 effectively. I know it's 4 over 4, but it is, the value of it is 1. And the beauty of that is when you multiply something by 1, you don't change the value of it, you just change the way it looks. So now this 3/5 is now 12/20ths, so that's now 12 over 20. It's the same value. In fact, when I go to the calculator, I put 12 over 20, it will come back and say, well, hey, that's 3/5. So that's kind of interesting. And then the 1/4, I have to multiply that times, well, 5 over 5. Again, multiplying it by 1 with a very strategic reason so that I can get this to be 5 over 20. And now I do have a common denominator, so I can see that that's where the calculator is getting 17 over 20. So hopefully that's kind of like, yeah, I kind of remember that. I understand that now. Well, I'm going to use that logic here. We're going to, well, there's a Grumpy Fish. Grumpy Fish says, nothing bothers me more than having an imaginary number in the denominator. All right, that's Grumpy Fish. All right, he's not very happy. He doesn't like imaginary numbers in the denominator. So here we have a fraction. There's an imaginary number in the denominator, and he says, get that out of there. Or he says, get that out of there. So we're going to multiply this, well, kind of like that big 1. We are going to multiply it by 1, but it's a very strategic one that we're going to multiply it by, and we're going to use this thing called the complex conjugate. We're going to go to this denominator, and in Spanish, when you conjugate a verb, so I've been told, is that you're changing the ending of it. Well, when you conjugate the complex number down here in the denominator, you're going to change the ending of it. So I'm going to make it 3 plus 6i. And if I multiply the bottom by that, I have to multiply the top by that as well. All right, so let's see how that plays out. So on the bottom here, I'm going to multiply these two. That's a binomial times a binomial, or a complex number times a complex number with two things, two components. 3 minus 6i, and 3 plus 6i. And 3 times 3, of course, is 9. Over here I get negative 18i. And down here I get 18i. And then over here I get negative 36i squared. Barely fit that in. Alright, so what's interesting about that, I think, is when you combine like terms, you're going to recognize that the negative 18i and the 18i are going to cancel each other out. That's the kind of cool part about that. So instead of 9 minus 18i plus 18i, it's just 9, and then minus 36i squared. So Grumpy Fish, well, he was going to be happy, but I still get this I squared. But we recognize that with our IFACS chart, that I squared is the same thing as, you might remember, as negative 1. All right? And so we can replace 9 minus 36i squared with 9 minus 36 times negative 1. All right, and when you do that, then we're going to get 9 plus 36, or 45. So kind of interesting there. All right, so we get 45. And then on the top, I'm going to do this one kind of in my head with a little bit of, well, not in my head. I'm going to show this. First two terms, I get 30. The outer two terms, I get 60i. Treating I like a variable. The inner two terms, I get negative 21i. And the last two terms, I get negative 42i squared. All right, so a couple things are going to go on here. I'm going to combine my like terms. So I got 30, and I got plus 39i. That was 60i minus 21i. And then I've got, I'm going to replace I squared with negative 1, and that's negative 1 times negative 42, or plus 42. I'm going to do a little rearranging and combining. 30 and 42, that's 72 plus 39i. 72 plus 39i. Alright, and I would love for that to be my answer, but I believe that 3 goes into all of those things, all of those numbers. So, in fact, a little quick math over here, 72 divided by 3 is 24. So I'm going to do, because all of the terms are divisible by 3, 72 gets reduced to 24, 45 gets reduced to 15, and 39 gets reduced to 13, and that I is still there. This is one way to write that. Another way to write it is 24 over 15 plus 13i over 15. So either of those are acceptable. Sometimes people break them out so they can see if they can further reduce. And I don't think I can reduce these any further, so either one of those would be acceptable answers. So the next one I'm going to let you, if you want to try it, well, I'll do it real quick. It's I'm going to multiply this time because it's a little bit different. It's 3i, 3i. All right, and you might say, well, wait a moment. You changed the ending for this complex conjugate. This didn't have a number in front, but you can think of it as 0 minus 3i. So this one would be 0 plus 3i. I'm going to take that 0 off of there to reduce any complications. Down on the bottom, I got negative 9i squared. That was easy. On this one, I'm going to do a little distributive property. All right, I've got 3i times 9 is 27i, and 3i times 6i is plus 18i squared. All right, now I'm going to continue to reduce or simplify. That I squared that's down here gets replaced with a negative 1, so that's negative 9 times negative 1 is 9. And on top, the 18i squared, the I squared, gets replaced with a negative 1, so that's negative 18 now. And then plus 27i. And I'm kind of hoping that you look at those and see that all 3 of those are divisible by 9. So that's negative 2 plus 3i over 1. And I certainly don't have to include the 1. That's negative 2 plus 3i. I divided or reduced that entire set by dividing every term by 9. All right, take a deep breath and go try some of those problems.